everyone. Welcome to SECtember. My name is Dr. Christopher Porter. I'm representing Google today. I'm our head of international security cooperation, and for several years was our head of threat intelligence for Google Cloud. So I'll be talking today about how we at Google defend our own cloud infrastructure, and also broadly how do actors try to exploit that. So really focusing on the infrastructure, both digital and to a lesser extent physical, that undergirds a lot of the AI magic that we're all learning so much about. Just to talk briefly about conceptually how do you reduce risk when you're talking about a global hyperscaler? We have, Google has operations all over the world. Um, how do we think about not just securing one computer or one organization or one instance or even one, data facility? How do we secure the whole thing? And you sort of start with thinking about protections and security for all the different levels of the OSI model. So we don't want to just think about the digital level or countering APT groups. We want to think about physical security. So at any given point, roughly 25% of the global internet goes over Google's fiber or data centers. We need to make sure we have physical control of those pipes, of those facilities. Then you start thinking about logical like access control. Then, yes, you start thinking about how do we deal with remote exploits. But even if there are remote exploits, what about the data that is inside of each instance? Is there a way to secure that? And that's where you have functions like zero trust, where we assume that any organization, including our own, has been compromised, and you think about the kind of controls you need to minimize damage. But I guess what I want to emphasize for today's lecture is just that it's all levels, and you really have to start with that foundation of what is your physical security? What are the physical systems that is doing the compute and hosting the data for you? Do you trust that they have good procedures and security? If you have higher level, digital controls and logical controls, but you've failed at that foundational level, that's not going to work. You're not going to be secure. So I want to talk briefly before we get specifically into cloud about what the overall global threat picture looks like from an on-premises perspective. So the data that you see on screen, this is from last year's M-Trends report, our Mandiant side, which is the commercial incident response and intelligence consulting side of Google. Our client base, this is where I work, our client base is roughly, for last calendar year, is roughly 90% on-premises, say 10% cloud. Just order of magnitude. It goes up every year, so maybe it's a little higher this year, but it's roughly 90-10. And the customer base is going to slant towards better defended, higher spending, larger organizations, and is not necessarily representative of small and medium sized businesses, although I think it's probably similar. But broadly speaking, globally, when we do incident response, almost 40% of the time there's a remote exploit involved. That could be a 0 day. We saw more than 50 last year. But overwhelmingly, it's a known vulnerability that in theory could have been patched but is being exploited. You can see phishing, stolen credentials. These are in the low double digits, a little over 10 to 20% for each of those categories. Once we conduct an investigation and kick the bad guys out and clean the network up, and we track back and figure out how they got in, roughly 40% of the time it's some sort of remote technical exploit, credentials stolen or directly phished from the user less than a third of the time. In the cloud, in Google Cloud, but I think other cloud, hyperscalers are going to have very similar general shapes of the problem. We're looking at much higher rates of either threats to identity, such as stolen credentials, leaked credentials, or where maybe something doesn't have a password at all. A SQL database doesn't have a password at all, and it's exposed to the internet. It's supposed to be internal only to their instance. So that's both a misconfiguration and a credential problem. Well, together that makes up 60 to 70% of the breaches that we see in cloud. There are far fewer breaches, so being in the cloud makes you much more secure. The problem shrinks, but it's not like the criminals and the nation state hackers just give up and say, well, you're in the cloud, we can't possibly get in. Instead of attacking technology like they do in an on-premises environment, they mostly focus on identity. Can we attack identity somehow? Technical exploits in the cloud, we're talking low single-digit percentages. I would say it's almost always under 2% every quarter when we do this. So think about that. You're going from almost 40% exploits in an on-premises environment to low single digits, typically under 2%. That's an order of magnitude reduction, really an incredible reduction in your threat surface. But percentage-wise, it's being replaced with a greater emphasis on stealing credentials and that sort of thing. It could also be as simple as, let me go on LinkedIn enumerate all the employees who work at your organization. Think about, well, how could I figure out their passwords? You could phish, but you could also just take their names and look at these gigantic databases on the dark web of known leaked passwords from other websites, write a little script to try every password that's been leaked from every employee, try to log in remotely. And in fact, we do see that. We do see criminals and sometimes nation states do credential stuffing. And you might think, well, how could that possibly work? Somebody would reuse their Netflix password at work or something like that, and it would be leaked. But if you have 1,000 employees, 10,000 employees, that means they can take this kind of spray and pray approach using widely available leaked password databases, simple scripts, simple scraping of your LinkedIn presence for your employees. And they probably know the format for logging in, first name dot last name and organization.com or whatever. That's really simple to put together. And even if the success rate is 1/4% or 1/10%, you're still going to get plenty of beachhead if it's against a large organization with thousands of employees. Happens all the time. Very common entry vector is reused passwords that have been leaked. Now let's go into a little more depth on a particular actor. I'm sure as I've been talking, some of you have been wondering, why North Korea, for example. Actually, when it comes to innovative, cloud-centric, cloud-native, innovative techniques, North Korea is one of the, if not the leaders in sort of inventive, creative ways of getting in. The most common way, and probably the most dangerous way that North Korean, these are nation state actors, right? Military and intelligence actors. The most common way that they get in is, eventually they're asking for credentials or trying to push you malware, but really the magic of the operation isn't the phishing, it's the rapport building over a long time. It could be weeks or months of talking to someone over LinkedIn, other social media, Telegram, convincing them that they're a consultant or a potential business partner or something like that, and really building up that rapport over a long time, really a good relationship before they ever push anything malicious. When you work in cybersecurity, I think there's a focus when we talk about APTs, advanced persistent threats, there's a focus on the advanced part. Researchers, it can be hard to impress over a long career. You just, the bar for what impresses you goes up and up and up. But actually, the most dangerous part of an APT group isn't the A, it's the P, it's the persistence. So having a skilled, language-capable person, who's good at convincing people to do things they shouldn't do, develop their target over a long period of time, and a pretty good success rate for this. The technical magic can come on the cloud side when they push, for example, it could be a fake login page, very straightforward phishing. It could also be a request to the target to install an app in their enterprise environment. Install this app, and then the app itself asks for your single sign-on permissions. The user's never asked for a password. They're never asked to do anything intrinsically, technically malicious, but they should not have given, certain permissions on their account to this app. It all looks legitimate, and particularly if you have a noisy kind of corporate environment that allows installation of cloud apps, I think a lot of users probably don't do the vetting, or they have no way of doing the vetting and no reason to suspect anything malicious. Well, those apps may pull sensitive documents. The North Koreans have also shown a great deal of skill at picking up tokens, using that to bypass security controls, hijacking cloud sessions mid-session. It's not necessarily technologically difficult. It's just, I would put it in the category of clever. But what that gives you is an ability to bypass two-factor, right? If you can hijack a session already in place, then you don't need the two-factor push. If you can, give someone an app and that app can get permissions to read documents or emails, for example, it all seems very natural, uses the user's existing permissions, doesn't necessarily require a new login, or if it is a new login, it's legitimate, it's through their corporate environment. So it all kind of evades detection. So very clever, kind of operations there. The targets of North Korea's operations most commonly are financially motivated. They might get a legitimate remote work job in an organization and just work 5 or 6 of these. Obviously, purchasing power parity in Pyongyang is going to be much greater than it is in the West, and so those are even more lucrative than they sound. And they're just bringing home cash for the regime and for the nuclear weapons program and so forth. A smaller percentage of the time, but we still do see this. The North Korean workers are attempting to gain access to essentially software supply chains. They're going after interesting companies that are B2B, maybe the backbone of other companies, or they are somehow involved in cryptocurrency. They can steal the cryptocurrency, but they, in that small percentage of operations that are software supply chain based, we do see a focus on getting North Korean malware put into a legitimate organization's code, kind of Trojan horsing it in like that. This is particularly prominent in South Korea. They will try to compromise the maker of a mobile app and then do an update to the app by pushing up their own code inside of a real vetted, trusted company's app. So it's not the main thing they're doing, but it is common enough that it does appear that these are not just financially motivated, but they also are working to collect intelligence or other kinds of things. It used to be that a lot of these remote workers just got jobs in the US or in Western Europe. Over time, there's been enough attention from us and from others that the police and security services have largely disrupted that. You see an increasing focus on basing these operations out of Eastern Europe for a variety of reasons. They still do try to land jobs directly in the UK or in the US and a smattering of other Western European countries, but really a heightened focus on getting these remote work jobs, from Eastern Europe, potentially using them as an inside out game, getting a job, or maybe also compromising them other ways. Over time, the placement of the workers, really the targeting has gone all over the world. So what was a South Korea, US, Western Europe problem has become truly a global epidemic. As I said, if you break down the sectors, they're mostly making money. I mean, insurance, retail, those are not places that typically have a lot of intelligence value. Legal and professional services, probably again, mostly financially motivated, but it can also be valuable for intelligence. Telecommunications, I think you start talking about, more direct intelligence collection. They do use some novel uses of AI to do this. These are with the virtual screens removed, these are their actual work environments. You can see they have cameras there monitoring them while they work. But the virtual environments often look like typical, high-tech company work environments. But we're, very confident that these are not who they claim to be, that these are generally they're operating out of North Korea itself and using virtual backgrounds and intermediaries in the U.S. historically, but also Eastern Europe now to be the middleman in their operations. My career has been spent in intelligence analysis. A lot of Silicon Valley companies have jobs like chief solutions architect. I'm kind of Google's chief problems architect. All I do is think about threats all day long. But I don't want to stop today's discussion just with the threats and how people are getting hacked and what the North Koreans are doing. I want to talk briefly about the advantages that AI has for defense. Net long term, this is one area where I'm actually an optimist. I think AI is going to be a huge boon to intelligence analysis and cybersecurity. I'll just talk very briefly about what that looks like. At Google, we already do a lot of this in our internal workflows. I've worked here 3 years and it's changed a lot, mostly over the last 2 years. Not automating away jobs, but empowering skilled individuals to do their job at larger scale and more thoroughly and in better ways. Not a human assisting. You can create, and we do internally, a variety of agents to operate on your behalf, to go do research and to conduct actual cyber defensive measures, but semi-autonomous, doing the background stuff, letting the really high skilled work be done by employees. So I'll give you an example. Since long before I worked here, Google has used machine learning, at the time we were just at machine learning, to find bugs in our code. And not just in our code, but in open source packages that we use in Google Cloud and recommend for others and so forth. So most, entirely our code, but also some other important public open source packages. But using this study on our own code, we used the same kind of, customized for security, but the same underlying foundational Gemini model to not only detect, but to try to fix some of those bugs. So we used our normal process. And we said, how often can Gemini just automatically fix a security bug or other bug that we find in our code? And we found that it could reliably do it 15% of the time. If you think about that from our perspective, even though we have, I think, the best software engineers in the world and a lot of them, this is like getting 15% more of your time back, right? You don't know a priori how difficult a bug will be to fix. These are generally lower difficulty bugs, although they do find more obscure ones as well, but they're generally lower skilled kind of bugs. But if the machine learning turns up a bug and you're trying to fix it and it requires a human expert, they don't know until they look at it that it's going to be easy to fix. This is freeing up an extra 15% of our workforce equivalent. Huge gains for us internally. Now that's on the sort of workforce scaling. On the quality side, VirusTotal, which is a repository of all the major endpoints, antivirus vendors, including our own, running AI against that database, 70% better at preventing false negatives, essentially better detection rate for malicious scripts, 300% less likely to miss a script that exploits an actual vulnerability. So some kind of scripted vulnerability exploitation. The more you can write out what it is that you're looking for, right? Here's a database of known bugs. Here's all the known 0 days and so forth. The more we can do that, even if the code really obscures that, if we train our AI on the function of what it is it's looking for, and also if it's able to run it in a virtualized environment and see how it operates and does it look suspicious or not, we've really made huge gains in our ability to detect malware. Just from that one edition, which is now available to everyone if you subscribe to VirusTotal. How do we use it for intelligence analysis? Many of you have SOCs and cyber intel teams. Keep in mind the most important thing that your intel analysts are going to be is not experts on malware or China or whatever. They're going to be experts on your organization and what kinds of decisions your leaders are making. And as they read intelligence, they're going to filter through that. What do my leaders need to make a better decision, either at a security level to take immediate action or at a strategic level for the C-suite to do resourcing and policy? Gemini really speeds up the process of gathering reports. So I use this all the time. Tell me about all the recent compromises in our database in, the German pharmaceutical industry. And I can do that. I can pull that myself, but instead of taking hours or days, it takes a couple of minutes. And I have all those reports. Really importantly, you as an individual organization, probably you have some kind of cadence with the Intel team where they check the reporting every day. Gemini can automate that for you, right? It can go in and make sure you don't miss any reporting. That's just as important. And finally, for our internal incident response team, we got a 51% improvement. In this case, what it means is we were able to answer 51% more investigative trouble tickets over this time period. Almost all of that gain from using AI for our incident response team didn't come from the investigation side. It came from writing up the reports. Take all these notes and PCAP and files and whatever else you have multimodal, right? Take all the different kinds of data you gather during an incident response investigation and write a first draft of my report of the incident. Some IR people are going to be great writers. Many are not. They're technical experts, and writing may not be their strength. We were able to train, this LLM on what we thought were the exemplary, good, well-written reports, and tell it, hey, for this task, I want you to take the data in that we give you and write reports that look like these exemplar reports. So not only did we get a 51% improvement in use of our time, we also got an improvement in median quality. So that's just for you to be thinking, what's the art of the possible right now? Using AI to make sure you don't miss intel reports, using AI to help you write reports quicker so you can focus on the thinking and the expertise aspect. And I think eventually we and the world will get to where you're using AI to automate some first level defense. So for example, here as we have hacktivists making claims of compromising critical infrastructure, getting a first level triage that says, based on the background of this actor, do they make things up or do they tell the truth? Do they have a history of actually doing what they said they did? Also, what is this picture? What does it represent? You may be a cyber expert, but are you a control systems expert? Having that first line triage done for you and waiting for you really speeds things up. And in security, speed is the killer factor, right? It's quality, but it's also, can you take action quickly? I think state of the art available commercially today, from us and from others, I'm sure, you could speed up a lot of how your organization turns around new 0 days, new intel reports, new discoveries, new alerts on your network, turn around some first level actions, and being able to do that in minutes instead of hours or days really complicates things for the attackers. So a little bit of good news, not what I usually do. As you can see, for us, that also means being aware of, when you get, this is an example of like in a SOC, you get an IOC, what is the immediate, triaging of that? We use that all the time. I think being able to turn that around and having quick triaging is going to be an immediate, this year, sort of killer app for AI in your environments. And I hope you enjoyed this discussion, and you'll maybe sit in on a few of my future webinars that I do and enjoy the rest of SECtember. Thank you all.